Okay, let's move on to the next topic, which is optical flow. So the next logical step beyond template matching is to understand how to track objects between frames. So optical flow is very similar to template matching in that it takes a small area of one image and then scans the region in a second image in an attempt to find a best match. If a match is found, the system indicates the direction of travel as measured in XY points. Only the two-dimensional travel distance is recorded. If the object moves closer to or further away from the camera, the distance is not recorded. Now, if we look more closely at what is optical flow. So optical flow is the relation of the motion field, the 2D projection of the physical movement of points relative to the observer to 2D displacement of pixels, patches on the image plane. So a common assumption is the appearance of the image patches do not change. In other words, brightness consistency. And if you note, more elaborate tracking models can be adopted if more frames are processed all at once. If you look over here, we have point 1, 2, 3, and 4. If you monitor it with regards to the next frame, we see that point 1 has moved in this direction, point 2 has moved in that, so on and so forth. This shows that the object was here and now has moved to this point. This pixel was here and has moved to that point, and so on and so forth. There are quite a few optical flow algorithms out there. One is the phase correlation, the next is block-based methods, differential methods, and the Lucas-Ganade method, which is widely used. There's also the Horn-Schnuck method, the Buxton, Black-Japson method, and there's basically general variations of the above methods. If you want to know more, you can always check it out on Google and read a couple of papers on what they are about and how they work. Okay, so let's look at the motivation of optical flow. Well, we are interested in finding the movements of the scene of the objects from time-varying images or videos. This has a lot of uses, such as motion detection, tracking objects, such as in Adobe After Effects, correct for camera jitter, or basically use it for stabilization, aligning images, such as mosaics or stitching, 3D shape reconstruction, special effects, games, user interfaces, and video compression. Using optical flow for video compression saves a lot of space and can help speed up your video as well.